Hello friends, welcome back. In the previous tutorial, we have seen how to find out whether some game object is behind some other game object, or how to find out the player is in front of the enemy, or how to find out one object is in front of another object or beside. So this code is we have seen in the previous tutorial. So in this tutorial we are going to see one more example and solve that problem. Let us minimize and come back to the diagram. Here we have a diagram. Now let us take, we have the enemy over here and its x position is 100, y is 100, so we have a vector drawn. And let us take the player is at 500, 100 and its vector position vector is drawn over here. You can see this one is enemy and this one is player position vector. I can say PP and here I can say EP, just shortcut. Enemy position and player position we have here. Now let us take the enemy has a weaving angle and the weaving distance. That means the enemy has the ability to see 200 units up to here. This is the range, weaving range I can say. This is the weaving range. Within this range, that means if any game object comes within this area, that means if the distance between the player and the enemy is less than 200, then the enemy can sense it. That means the enemy can easily understand that, okay, I have the player within the distance, somewhere nearby I have a player, like that it can understand. But the enemy has one more the constraint, that it can see this side 180 degree, this side 180 degree. That means total it can see to 160 degree. That is its weaving angle. It cannot see beyond this. It cannot see this side. If even though, let us take, if you have a player over here, let us take if you have a player over here, of course it is in the weaving distance, because the distance between enemy and the player is 100 unit, right? But it cannot see, it is not in the weaving angle. If the player is within the weaving angle and the weaving distance, then only the enemy can sense the player. So how do we implement this code? Also you can say that if the player comes within the weaving distance and the weaving angle, then the enemy can start shooting, or it might start chasing. Understanding? So such a facility if you want to implement in your game code, then how do you identify that, or how do you solve this problem? How do you write a code for this problem, or how do you identify whether one game object is in another game object's weaving angle and the weaving distance? Now let us proceed and solve this problem. Now we have simple steps, we are going to follow that. Now what I am going to do means, I am going to write here the code. First I create vectors. Of course I need two vectors, vector 2D. The first one is the enemy position. Let us take E position is equal to new vector 2D, and the enemy position. What is the enemy position, guys? Enemy position is at present 100, 100. So let us say here 100F, 100F, that is the enemy position. And I create here vector 2D P position, that is going to be the player position is equal to new vector 2D. Here I have missed I. Player position is at present, you can see that it is at 500, 100. So what I do, I just create a vector 2D 500F, 100F. Save it. Now we know that here we get the player position and the enemy position vectors are ready. Now what we have to do, first we are going to check whether the player is in the enemy's weaving distance, whether the distance between the player and the enemy is less than 200 units. You can see that from here to here 100 unit, from here to here 100 units, so total 200 units. If the distance, at present the distance is, you can see it is 400 units. So of course the player is not in the weaving distance of the enemy. Let us calculate that. What we do means we first get the direction vector. We are going to create another vector 2D. Let us take vector 2D. The direction vector is equal to new vector 2D. Now what I am going to do, I am going to calculate the direction vector. I need a vector from enemy to the player. So P position minus E position I have to do. What I say here, P position is equal to P position minus E position, which is going to give me a vector from enemy to the player, that we know that, and we can see debug.log, and I can display the direction vectors dot x plus double quotation comma double quotation plus direction vector dot y, and you should see direction dot x and y should be 500 minus 100. We have to get direction dot x 400, 100 minus 100, I have to get direction dot y 0. Let us save and come back to Unity and let me run the code. You can see that we have 400 comma 0. That is the direction vector from enemy to the player. So you can say that we have received, or we got the direction vector from enemy to the player, which is actually 400 comma 0. This is the direction vector D, guys. If I arrange D and EP in a tail and head format, we know that we are going to have the direction vector from enemy to the player looks something like this, right my friends? This is the direction vector. Now we are going to find out what is the magnitude of the direction vector. If the magnitude of the direction vector is less than the 200, then we can say that the player is within the enemy's weaving distance. But by seeing this graph only, we can say that it is not in the weaving distance. So let us calculate. What we are going to do, we are going to first display debug.log direction.magnitude. I just want to see what is the magnitude. Magnitude must and should be 400. That you can see in the graph only, we can identify that 100 unit, 200 unit, 300 unit, 400 unit. That is the length of the direction vector. So let us come back to the Unity and run and check. If I run the code, you should see the direction vector value should be 400. You can see here it is 400, and we know that the weaving distance of the enemy is 200. So I can say here is if direction dot magnitude is less than 200, if less than 200 f, I'm going to delete this one, I'm not interested to display. If it is less than 200, then we are going to say debug.log player, player, player is within the enemy's enemy's weaving distance. And we know that at present player is not within the enemy's weaving distance. We are not going to get this output. I can say else I can debug.log and paste it, player is not within the enemy's weaving distance. Let us save. If I run the code, we are going to see player is not within the enemy's weaving distance. So we come back, and if I run the code, you should see the output as player is not within the enemy's weaving distance. Understanding? So this is how you are going to check out whether the enemy is within the weaving distance first. As it is not within the weaving distance, we need not to check whether it is in the weaving angle. Understanding? We need not to check whether it is in the weaving angle. But if the player is within the weaving distance, then we can check whether it is in the weaving angle. So what I need to do, I need to move this player from here to here. Let us take, if I move the player over here, at 300 comma 200, then the player will be within the weaving distance, right guys? So what I can do is I can add a velocity vector. I can create one velocity vector over here. I can say here vector 2D, or I can just simply write directly here x is equal to 300 and y is equal to 100. That will set the player somewhere else. So I just say Control Z, because we will be calculating again the weaving distance, weaving angle, all these things once again. So at present the player is over here guys, 300 comma 100. So we know that we are not going to have this. We are not having the player over here. This time the player is somewhere else. So player is at present 300 comma 100. And enemy is in the same place 100 comma 100, and the vector position vector of the player is going to look like this, and this is going to be P position vector. We have a P position vector 300 100 and enemy position 100 100. Now this time if you calculate the direction vector guys, we know that 300 minus 100 is 200, 100 minus 100 0. That is what we get here, right? Here we get 200 comma 0 direction vector, and if I calculate the direction dot magnitude, we are going to get 200 over here. Now let us check it out. Debug dot log. We are going to get direction dot x plus double quotation comma double quotation plus direction dot y bracket close semicolon. I just delete this part, or I comment this so that I can reuse it. I comment this part, and you should see here 300 minus 100 200 and 100 minus 100 is 0. Let us save and come back to Unity and run and check. You should see here 200 comma 0. We got 200 comma 0. That is good. Then I am going to display the magnitude now. Debug dot log direction dot magnitude. If I display, I should get 200. Let us save and come back to Unity and run and check. We should get the result as 200. You can see that we have got 200. Good. Now we come back and we check this time if direction is less than or equal to 200. I check less than or equal to 200. If the magnitude is less than or equal to 200, then we have to say that player is within the enemy's weaving distance. Of course the magnitude is 200, so this condition is going to be true. Player is within the enemy's weaving distance, it will display. Let us save and come back to Unity and run and check. You can see that player is within the enemy's weaving distance. Nice. This is how you are going to calculate guys. Now we have to calculate whether the enemy player is within the enemy's weaving angle. So how do you calculate that? As we know that player is within the enemy's weaving distance, here what we are going to do, we are going to use the angle method of the vector. We know that the angle method is a static method, returns the angle in degrees between from and to. So what we are going to do, we are going to first normalize the direction vector, or we can just say direction vector dot normalize. If I say normalize first, if I normalize, we know that it is going to normalize the direction vector. It keeps the direction same, but the magnitude is going to be 1. And we are going to create one float variable. Let us take angle. I am going to get the angle by using vector 2d dot angle method I am going to use, and to that we have to pass from and to. How do you find out the angle? From to. So here you have the right vector. You are going to find out the angle between the right vector of the enemy and the direction vector. If angle between the direction vector and the right vector of the enemy is greater, if it is lesser than 160 degree, if it is lesser than 160 degree, then it is in the weaving angle. So how do you perform that operation? Here we are getting the angle we are going to say I need the enemy's right vector. So I say here new vector 2D. I pass here 1 comma 0 bracket close. We know that 1f 0f indicates the right vector, and I also pass the direction vector. Now we are going to get the angle. We are going to get the angle between the right vector and the direction vector, and we display that debug.log display the angle. And if you see here, the angle should be 0 degree. Why? Because if you see in the graph, there is both are pointing in the same direction. The right vector and the direction vector both are in the same direction, so definitely the angle will be 0. Let us come back to Unity and run and check. If I run the code, I should get 0 degree as the last output. You can see that we have got 0 degree. Player is within the enemy's viewing distance, and the angle between the player and the enemy is 0, guys. So if the angle is less than 160 degree, 0.0f 160 degree, I can say that player is within the enemy's viewing angle. Player is within the enemy's viewing angle, ANGLE angle. And also I can say here enemy, ENEMY, enemy starts chasing the player, start chasing the player. Let us save and come back and run and check. If I run the code, I should see the output as player is within the enemy's viewing distance, player is within the enemy's viewing angle, so enemy starts chasing the player. You can see that how interesting it is. Actually, we did not to check the less than 160, we have to check less than half of the total angle, because we can say here this side 80 degrees, this side 80 degrees we are going to check, so that we can say that it is within the viewing angle. So it's a simple code. You can see that how do you perform this place. Actually you are going to write the code how the enemy chases, or what enemy does in this place. You are going to write the code for that. Okay, so it's a simple code, guys. I hope you guys have understood how do you find out how do you implement whether the player is within the enemy's viewing distance and the viewing angle, and how you are going to find out that, right? It's simple. You can check for some other example. Let us take this time I am going to say Control Z everything. Let us say Control Z. Let us take this time the player is somewhere over here. Let us take the player is over here, right? So we know that the player position vector is going to look like this, and at present the player is at x 100 and y is 300. And now you are going to find out whether the player and enemy are in viewing distance and viewing angle. You can see that the player is within the viewing distance, because the distance between the player and the enemy is 200 units. That is good, but it is not in the viewing angle. The angle is actually 90 degree. You can see that the angle is 90 degree. So the angle between the right vector and the players here, the direction vector will be 90 degree. So definitely it is not in the viewing angle. We are going to get the output. We have to get the output as player is not within the viewing angle. So here I am going to say else debug.log. I copy this and I paste here player is not within the enemy's viewing angle. I write here code. Now let us change the player position. X is equal to 100 and y is equal to 300. That is the player's position, guys. Now you can check it out if you want. I can comment from here to here. This complete code I comment so that we need not to execute it. Let us save and check out. Of course here we are going to get 100 minus 100 is going to be 0. So x distance is 0, of course. 300 minus 100 is 200. If you debug.log, you can see direction.x plus double quotation comma double quotation plus direction.y bracket close semicolon, and I also display debug.log direction.magnitude. Of course, we know that we get 0, 200 and the magnitude will be 200. Let us save and come back to Unity and run and check. And if I run the code, you will see the direction.x is 0, y is 200, magnitude is 200. Of course, it is in the weaving distance, right, my friends? So you can check that by removing this, and you can comment from here to here. We can say, let us save this, and you can see that if direction.magnitude is less than or equal to 200, it says player is within the enemy's weaving distance, otherwise it says player is not within the weaving distance. Let us save, and I am going to delete these things, not necessary to see, we know what is happening. Let us save and run and check. If I run the code, you must and should see the output as it is within the weaving distance. Player is within the enemy's weaving distance. Nice. Now we have to find out, as it is within the weaving distance, we have to find out whether it is weaving angle. So for that we are going to say direction.normalize, and then we are going to get the angle between the direction vector and the enemy's right vector. Right? If I save and run the code, you must and should see the angle debug.log angle, and here you are going to see the angle as a 90 degree now, right? Because 1f 0f, the direction vector is at present 0 1. So you save and run and check. Even we can display the direction.normalize also, debug.log direction.x double quotation plus double quotation comma double quotation plus direction.y bracket close semicolon. This one I display a little later. I need not to calculate angle also. Let us save. We have the direction vector, guys, which is actually, we have seen 0, 200. If I normalize it, let us check it out what we get. If I run the code, you should see the output normalized direction vector, which is 0, 1. Right? So we have 0, 1 direction vector and 1, 0 right vector. They are exactly at 90 degree. You can very easily say that they are already 90 degree. So if you save and display the angle, you must and should get the output as 90 degree. Let us save and come back to Unity and run and check. The last output should be 90 degree, guys. You can see that it is 90 degree, and of course we know that player cannot see above the 80 degree and minus 80 degree. So definitely we are not within the weaving angle. So as it is not within the weaving angle, as this condition is going to become false, it says player is not within the enemy's weaving angle. Let us save and come back and run and check. You can see that player is not within the enemy's weaving angle, so enemy will not chase the player. So this is the simplest code and easiest code, guys. Try to understand this. It's very simple, and you have solved one more problem which is really useful in games. I think for this tutorial this much is enough, guys. I hope you guys have understood how to implement the weaving angle and weaving distance. Thank you, guys. Thank you very much. See you in the next tutorial. Keep learning, keep coding.